Awesome. Okay, so everyone, thanks for joining today's GitLab University session. Pablo is going to be speaking about high availability. So Pablo, if you want to share your slides.
Start, okay?
Yep, we can see the slides. Perfect.
Cool. Okay, let me quiet my craziness for a little bit. Yeah, okay. So let's talk a little bit about what high availability is. This is not intended to be a highly technical conversation, but rather an explanation of what is it good for, what it actually is, how can that be valuable to our customers, where are we standing in offering this. So first of all, we're going to talk about the definition of what high availability is. Then we are going to talk about what complexity does it bring to the table. It's all about trade-offs in the end. We're going to talk about using a GitLab real-life example because we are using high availability in GitLab. So we can basically share what kind of problems it brings to the table and what good does it bring to the table too. How do we do it, basically? And what kind of customer can value this? Because it's not for everyone, honestly. And finally, we're going to be talking a little bit about what Premium Supports is offering right now for high availability. And how do we plan to ship this eventually as a feature in Omnibus? So first of all, high availability. It's a characteristic of a system which aims to ensure an agreed level of operational performance for a higher than normal period, which is normally known as an SLA, right? We define that we want to have 99.9 availability, which means that it has to be up all the time in the year, except a few minutes, whatever. The way I understand it is to have a plan B, basically. So what does it mean? It means that a system is going to be working without interruption or with a little interruption, tolerating that some components fail and basically go dark, right? For example, a disk fails at some given point, or a whole node dies and you cannot take it back, and your system keeps working as if nothing is going on, right? That means that there's more than one component on the system, right? If you want to have a highly available application and you need a database, you're going to need two databases, because if one dies, you're going to need the second one to take over, right? Which means that some components are in passive mode, right? For example, in the case of the database, you're going to have the first database who's basically serving all the traffic, and if that one dies, the second one that is actually following the first one is going to take over, and all the traffic is going to be sent to the second one, and then we're going to basically switch them back again, and so on. Some other components can be horizontally load balanced. It means that we may have some components that we have many, and we're going to put one specific component in front, which is called load balancer. And this load balancer is going to start sending the traffic or the requests to each one of the elements that it's behind it. We can talk about that later with how GitLab is reaching high availability. And it means that some components do not keep state. For example, the web servers. Our web servers right now do not keep the session. It has to be like that. Because if you are reaching GitLab with your session and you're going to get the web server 1, that's going to be one thing. But then next time you come by, you're going to get server 7. We cannot share the state among all the web servers easily, so they don't have the state, and the state is somewhere else. And finally, it means that the system can recover from a failure without customer impact, right? If my database dies, the customers, the clients, should not feel it in any way, right? Should not have any customer impact. High complexity. As a start, everything you have, make it double. right? But it should behave as a one thing, right? So we were just saying a database, right? To give you a sample of this, the database we have right now has 256 gigabytes of memory and is using 130 gigabytes of disk, right? So we need two of those all the time awake, right? So you have to consider that you will need a lot of resources to actually get to this point. Right? Failure scenarios get weird. That's probably the way of saying it. Fun fact about computer science is that the time is not linear and the time can actually go back in time. So troubleshooting when 20 machines do not agree on something can get interesting. We have been in war rooms trying to understand exactly what happened. A lot of really smart people, and sometimes reaching the point of saying, okay, I think we have a rough idea of what happened, but never actually got to the point of, okay, we can actually solve this. Solving a problem here is way much more complex, right? And you cannot write one thing anymore, right? For example, if you want to use a temporary file and you're writing a temporary file in the node 1, the node 7 doesn't know anything about it, right? Because you have many. So you need to start thinking about some things will need to be shared and some things will need to be completely local. That increases complexity a lot in the way we build the system, as I said. Managing these systems is harder, right? And finding the skills to actually support it it's harder too, because you need people who actually understand the fact that you have many times the resources and they are behaving each one individually, but they have to be trained to behave as a one thing. That makes everything much more harder, right? The trade-off is that you're going to have less downtime, but it may be too expensive, right? So you really should consider if you want to have that. Some real life examples, right? A recent case, we had the GitLab Splitbrain postmortem, right? You can find it in that issue. The problem is that we had 6 hours of data loss, right? That's customer impact in a nutshell, right? We had data loss. Only understanding what happened was hard enough, and sometimes there is no actual fix, right? The moment when we actually realized that we had a split brain, so just to explain a little bit, split brain, as I said before, we have two databases. One is working as a follower of the first one, but they basically disagreed and both started acting as they both were the master. So they both were taking data in, right? The moment when we actually discovered that this was going on, we had to kill one of both, right? And that's what is called shoot the other node in the head. And we had to do that, and that's the data loss we had, right? The problem is that getting to the point where we actually realized about that was really tricky already, right? So again, we are going to need a lot of skills and specific monitoring and a lot of work to actually understand what's going on when things go wrong, right? What's the good part of this? GitLab deployments. We can deploy mostly with no downtime generally, right? Because we can deploy in only one of the nodes, one of the web servers, and let the other ones work with the previous version of GitLab, and that allows us to basically have a 99.9 uptime, which is, I think that's the one this month, but that's cheating because we only have 4 days in this month. But it allows basically to keep the application running all the time, right? The service is available all the time, mostly, right? So how do we do it? We have 5 load balancers in front, all with the same IP, right? As I told you before, the front gate is going to have many machines that are going to be basically getting one request and sending it to the first node, then to the second, then to the third, etc. That's called round robin, right? They're going to start balancing all the way in to distribute it to whatever's behind them, which is 20 worker nodes. That's what we have right now, which means that we have 20 web servers and 20 background jobs running all the time. And this is basically 20 machines, right? So far you can see that we have 25 machines, and we are just getting in, right? We have two Postgres instances, one in active mode, one in passive mode. If the active dies, the passive is going to take over. That's usually how it works. We have two Redis instances. We use Redis as a caching mechanism and to share the sessions between the worker nodes, the web applications. And we have three NFS servers at this point, which means that we have three single point of headers because we don't have replication there yet. Two of them are used for Git repos, and one is used for shared resources. If one of the NFS servers goes down, we are going to be basically taking customer impact. We are going to be drop the service for a while until the NFS goes back again, right? It goes back up again. That's what it means to have a single point of error. If that dies, the whole thing dies. This is a graph that explains basically what we have. This is from the Chef repo. You can see that there's the internet. We have the load balancers in front. We have all the worker nodes. And then we have all these blocks, which are the storage, right? The three storages and the databases are there and the Redis are there, right? You can see basically how that's built. So you can see that this requires a lot of explanations. It's not a graph that you can basically figure out immediately when you see it. So that's the kind of complexity I'm talking about. It's not that you have one server with one database and you're writing files to the file system. It's much more complex than that, right? So who can use this? Well, customers with globally distributed teams that cannot stop pushing stuff, right? Apple, for example. They have people around the world. They have a lot of places where people is coding and reviewing stuff and working basically. They go around the globe, so they need it to be up all the time, right? Customers who have a public-facing installation, right? If you're doing anything that actually requires from people around the world to help you out, you're gonna need to have it highly available, right? Taking downtime may not be an option for you. Customer who has strong in-house engineering and can manage this level of complexity, but that's a requirement, right? If you wanna sell this to somebody who doesn't have that, it's like trying to sell a car to somebody who doesn't know how to drive, right? They will have the car, they will not know how to use it at all, right? And if it breaks, they will not even know that it's not working. Customers with good monitoring systems, right? This requires that you're monitoring a lot and that you understand what you're doing, right? With good backup systems. If things go wrong, you should be sure to have a good backup system, and that you can actually rebuild it if it dies. Premium support. I don't know if Jose, you want to take on this? If you're around. Else, I can take it. Yeah, he's not around, so I'll take it. So customer support, premium support will offer the design phase, right? How you can build this. We are going to be helping you to understand how you can actually build this. We are going to walk you through the design phase, and we're going to tell you what are the best practices that we have learned so far, right? We are going to support you while you are implementing this and while you are migrating, right? We are going to do the hand holding to basically spawn this up. we are going to help you to identify and fix issues or configuration errors. But as far as I understand, we're going to help you understand when something goes wrong that is basically on our side, right? And we are going to help you with the upgrades, right? We are going to offer support at that level. So what's in the future of high availability? We want to ship high availability as an EE product, right? It's going to be part of GitLab. It's going to be basically to have all the configuration in one place, to set up a flag and basically say, I want to have these hosts with these roles, and it is going to be installed as you ask, right? You will be able to do the same thing we're doing, which is upgrade the system without stopping. Of course, given some constraints, of course, but we will want to basically offer the same thing that we are doing, right? We want to start building a high performance infrastructure, which means that we will probably include some of the things we are including in our infrastructure to speed up your infrastructure. The case of what we're doing with SSH right now, for example. We want to make it horizontally scale as you grow, right? The same thing we're doing right now with 20 nodes, right? We didn't start it with 20 nodes. We added them as we needed them, right? We want to offer the same thing to our customers. If you need more power, you can have more power. Storage of your choice. Still, we're not offering highly available storage. We're working on getting that to GitLab.com first. And once we have it nailed down, we will start offering it back to our customers. This is a hard problem, a strong limitation that is in systems engineering in general. Further online, the SafeFS maybe as part of our installation, or at least offer it as a solution and make it as a supported file system if we can do it. This is, of course, thinking down the line. And finally, something we're playing with is to enable auto discovery of new nodes, which is the ability to actually, just spawn a new node and let it get seen by the rest of the system, and let the rest of the systems to start using it by itself. What is the competitive landscape? I briefly took a look at this. What GitHub offers right now is that they sell a secondary server that supports HA, but scaling will be challenging. So as far as I understand, what I read from their page, they basically offer you to have one instance and a second instance, and have a manual failover to the second one within 5 minutes in the case the first one is failing for whatever reason. And Atlassian, we are basically in feature parity with them. They have a few offerings there. And that's all I have. Any questions?
Yeah, I have a quick question. Could you go into detail a little bit more about the difference between like active-active or active-passive? Like I hear that thrown around a lot. So just trying to understand the difference a little bit more with that.
Sure, absolutely. So active-active, what it means to say that something is active, you will hear also to say master slave and primary and secondary. People use these words interchangeably. What it means, the classical pattern is to have an active and passive. What it means is that you have, for example, one database where everybody is reaching that database and writing to it and making queries to it, right? And you have a second one that its only job is to follow the first one, right? So whatever happens on the first one, that database is basically going to be writing a log, and the second database is going to read the log and do the same thing, right? It's basically following the first one. The idea behind having an active and passive is that if the first one, the active one, fails, the second one is in the same state, right? It's really close to the first one, so it can basically take over, and you can start sending the queries to the second one, right? That's the classical thing. That's what we are doing. When people talks about active, that's a harder model, right? You're gonna get into the world of the trade-offs and distributed systems, because that means that both databases have the same status, the same state at the same time, which means that they have to agree, right? So when you want to write something on the database, you're gonna tell that to the database number one, and the database number one is gonna tell that to the database number two, and then the database number two is gonna say, okay, I have it to the first one, and then the first one is gonna tell to the client, okay, it's done, right? They have to work as a one thing. They have to basically agree all the time. That in theory is great. The problem is that you are introducing latency, and if you start adding loads on top of that, basically they will start delaying in getting to this agreement, and that's gonna slow down the whole thing, right? I don't know if that's replying to, or if I'm answering your question.
Yeah, that does help. Thank you.
Well, can't you use CFFS in a way to mitigate that? I mean, I've run into a couple of people who, it's like, they want active, and that's all they want. They don't want to hear active passive at all. So I believe, if I recall correctly, we've offered them, well, here's how to use CFFS for that, but perhaps you can comment on that.
CFFS is a different kind of beast. CFFS is basically a distributed file system. A distributed object storage, which means that you can send an array of bytes. And Ceph is going to basically handle writing it in many places, right? It's going to handle all the craziness behind it. CFFS is to build a file system on top of that, right? I'm not sure, because of the model that CFFS works, it's not going to offer you a lot of performance, but you will, if you want to put a database on top of CFFS, you're going to put a complex thing on top of another complex thing, right? The idea of distributed systems, sorry, go ahead.
Can I ask a clarifying question? Is that active? Did they specify it's for the file system, or did they just say, I want GitLab to be active?
If you're asking me, they said, I want GitLab to be active. And if I recall correctly, and I've had 20 seconds to think about this, we told them that if they didn't want to use NFS because there was some problem with the AWS environment or whatever where they were looking at. So I think we suggested CFFS, and then Drew put together here's how to configure CFFS for them. So I think that part may be just for the Git repo part. But either way, it's interesting. I never, give a lot of thought to the distributed active part with the database, because that's really, as you said, the two-phase commit problem, which ends up being really slow. There's not much you can do about that.
Yeah, and they weren't satisfied with active application servers. Rap, is that correct?
No, they wanted something so that if one node went down, the other one would just continue. And with NFS, they felt there was really a single point of failure there. They wanted to make sure that one node could just completely go away without somebody having to do something.
Okay. So there are many things in this
yes.
conversation. So you can we have 20 nodes. If we're talking about nodes from the perspective of a web server, we have 20 of those. They can be horizontally scaled as much as you want. The actual single point of failure, and I think that they are basically agreeing there, is that the file system, right? If you take a look at the Atlassian page, they are actually saying that the file system is going to be shared among all the nodes, right? So we are in feature parity with them. We're not offering anything better than NFS still, but what we are doing is using CFFS, right? CFFS works in a way like an NFS, but the thing is that to build an actual CFFS cluster, you're going to be needing at least 10 hosts, right? the way it's going to work is that you're going to have a lower level of object storage, which is basically the buckets where you write the data. And you're going to have another layer on top of that, which is going to be a metadata, which works in an active passive mode. So you can have many of those. So if one dies, the other one's going to be picking it up. And what that stores is basically the file names, the nodes in general, right? And then you're going to have a set of monitors who are going to be keeping the state of the thing, right? If you think about it, I talked already about 3 roles. I'm not talking about the internals of the machines, and I'm saying that up front you're going to need 10 hosts, right? So it's not going to be a single point of failure, but the complexity just skyrockets, just to begin with, right? So you will not have that problem of it going down, or you shouldn't have it, at least. But you get into the distributed computing problem, and you need skill. You need skill. You need people who actually understand what scrubbing means, what thundering herd means, etc., etc., etc. Right? You need someone who can say what the cap theorem means.
Yeah, Pablo, can I add to that a bit?
Mm-hmm.
I think the first law of distributed systems is don't distribute, because it's very, very hard. And Ceph is a distributed file server, but in the end, as if I'm correct, there's one metadata server. So you still have one single point of failure. Only the advantage is that you can have multiple file servers. The file servers can fall over, but this new server, that is an active passive system. So if you're just only focusing on, we don't want a single point of failure and everything needs to be super fancy, mostly it depends on the customer, of course, but mostly they're over engineering it. In general, GitLab should not use any technologies that are fancier than anything they use in their production systems. Probably they're a business, they have customer facing things, and those things are more important to keep up than GitLab, probably. Like, it's not nice if all your developers are not doing anything, but it's even worse if your customers can't do anything for now. So if they're not familiar with technologies such as Ceph or anything like that, they should not start using these fancy technologies, because they are hard. They require teams of people to engineer. And in the end, if you have a single NFS server where you can just have a secondary failover server, that will be much more reliable than a whole Ceph cluster, unless you have a team of 5 people to take care of the Ceph cluster. So just saying that's a single point of failure, it shouldn't be there. Yes, they're right, it should have a failover, but insisting on active because it's better than active passive, that is a sign that those people do not have a lot of experience and they're optimizing the wrong things. Of course, I cannot comment on the specific situation, but I've been in very similar situations where people go to bizarre lengths, and in the end, what they mostly end up is either they do their crazy plan and they are in a world of hurt because it fails the whole time, or they just start off with a simple setup. We say to them, okay, well, start simple, and if it causes downtime, let's fix the problems as they arise. And most of the time, it's just totally fine. So if somebody says, well, the file system should not be a single point of failure and it should be active, the first pushback would be like, okay, what you're using as a file system for your production-facing client apps, and take it from there. And if they use something uber fancy there, then let's talk. But otherwise, try to push back. Rap, please go.
I was going to say the customer in which this has come up most recently wanted to do something in the AWS Gov Cloud, and there were certain limitations, I think, of using NFS between different nodes, which is why we ended up suggesting CephFS. But they had some specific governmental regulation requirements, I think, of to why they needed certain things. But I would totally agree with you. Every time, even in my prior life, when people want to do these things, you're absolutely right. The active thing is very difficult and causes a lot more angst than the actual problems that they would encounter once every couple of years.
Cool. Yeah, makes sense. And every customer is different, and this sounds like something more specific. Sorry, Pablo, for jumping in there.
Oh, no worries. I wanted to add that, in fact, there are, if you have a customer who wants to remove the single point of failure, there are specific products from IBM, etc., who offer basically clusters of NFS, so they can basically throw money at the problem. And that's generally a way of solving that. That said, when our NFS goes down, that happens because Azure decides to basically reboot it itself. We take, say, 6 minutes downtime, right? 6 minutes. If we're talking about 3 nines, that means that we can have a downtime of 8 hours, 8.76 hours per year, right? 6 minutes is not a big problem. So you should also push back on, do you really want to go that far to avoid having 6 minutes downtime? I mean, seriously, 6 minutes, go for a coffee.
Yeah, I think the general rule is every 9 you add, it makes it like 10 times more expensive or something, Pablo?
Yeah. And
so
it basically is going to block you to not do anything in the end.
Yeah, so you can say we're web scale, we need 5 nines, but you just increase your costs by 100-fold.
It means that then you can only have 5.26 minutes per year of downtime, which means that you cannot even install a kernel upgrade.
So it's a trade-off, and if people are screaming for 5 nines and they don't know what they're, then sometimes they're totally right, and we can learn a lot probably from their engineering team. But most of the times they don't understand the trade-off involved.
Yeah, I think that I think more in that line. I think that if you want to have 5 nines, you have to understand that you will need a really, really, really skillful set of people to actually keep that alive. Not changing it, not making it better, keeping it alive. Only that.
I have a question. Who within the organization is like typically responsible for the maintenance? Because you talk about like the skill level that's required to maintain a highly available setup. Who does that usually fall to? Like what role?
Usually that's production engineering who would take care of that, but we're using infrastructure as code with Chef, so it's kind of automated. We are actually pushing back some things back to developers. For example, deployments are done by developers by using automation. The only way you can start managing so many machines is by using automation. So that's basically the idea of DevOps, where you tear down the wall between system engineering and development. We both work together. So it is not that there's one final responsible. Maybe that's me. It is a joint effort of the whole engineering side of the company.
I have another question. Just so, oh, yeah, just one more for me. So on our high availability page, we also mentioned GitLab Geo. Can you just explain the distinctions? Like, I mean, I obviously know they're not the same, but because we do call it out on that page, I'm curious as to like what's the relationship.
I don't really know the product completely. What I understand as Geo is that you will basically have a closer replica. I don't know if Sid, you have more data on that.
Sorry, the question is what Geo is, or
No, not what Geo
Yes.
is. No, not what it is. It's just that we mentioned GitLab Geo on the page for high availability. And so my question is just more around like, what's the relationship? Like, was the purpose of mentioning it there that, you know, maybe people have sort of misunderstood what their needs are, and we have GitLab Geo as another way to just allow read-only access to the secondary like instance, or is there actually a stronger relationship between geo and high availability? Like, what's the recommendation of the two together? I'm just curious as to, we put them all on one page, so I assume that there's a relationship there.
Okay, I'm reading the page. Okay, now I know. What I understand as geo for the future is that's read only, right? So it is basically having a whole GitLab as a secondary node, right? It's like the idea of the database. So something that happens when you have an active and passive, you may have one database who is active and then have many that are passive, but you can actually reach them and read stuff from them, right? That's used to distribute load sometimes. That has nothing to do with high availability, just a distribution of load, right? The idea behind Geo is to have a complete GitLab instance as a secondary node that is following the first one, right? This can be useful if you have a team that is distributed through the world, right? Let's say that you have people in Europe and people in Australia, right? The latency of just the speed of light is going to be slow enough to sometimes make it really slow to read stuff, right? That time, Geo is useful because you can have a secondary replica who's following the first one all the time, but it's closer physically to you, right? It's just close to you in the same place in the world, right? That is generally the use of this secondary node.
That makes sense. So essentially, there's no relationship, between geo and high availability. We're sort of just mentioning it as another way that we allow for replication, it seems like.
I think that in the worst case scenario, if the master, the primary node goes down and is not available, you can probably still read from the secondary, right? But you cannot write. You cannot push stuff. You cannot send comments. You cannot do anything else.
Exactly. I think that is it. It lessens the impact of downtime, but it's certainly not a maturity level. So thanks for bringing that to the attention. And I just improved the page with a commit that I pasted in the chat here.
Thanks.
I'd just like to add to what Amaro said is that I found a lot of customers and prospects who are sort of confused by this issue. I'm not sure exactly what Sid just updated, but that would be good to update that to make that a little more clear. And the other thing is people are, I think, thinking they can use Geo, or at least wanting to use Geo in such a way that they know that it's passive, but if the active master goes down, they want to be able to turn the Geo copy into their master and just sort of move forward with that. And I know that we've said you can sort of do that, and but don't rely on it to be like flipping of a switch. So I'm not sure if you could speak to that to some extent, but I think that's what a lot of people expect out of it. So we can either make it so that you can do that, or warn them about it. But
Exactly. So as the page read, it was a maturity level. It was the final maturity level. This is not the case. I didn't see that edit. So I just unindented it. I'm making extra edit now. GitLab Geo is not a high availability solution per se. What we'll have for that is the highly available omnibus packages. That will be a high availability solution. So I'll add a link to that.
Makes sense.
Any other questions from anyone else on the call? Okay, it looks like no. Pablo, thank you again for taking the time to make the slides and presenting them and answering all of our questions. Thanks everyone for joining.
Any other question that you have, just ping me on the chat on Slack. I'm open.
Thank you. Thanks everyone.
Thank you.
Have a good rest of your day.
Thanks.
bye from across town, Amara.
Yeah.
Thanks, Pablo.
Bye all.
Welcome.
Thanks,
Bye.
Pablo. Thanks, Amara.